Welcome to qnawire.
In this question, we have this setup inside a motor. Gear A is meshed with gear B, and B and C share the same rotating shaft. And we are given that the radius of A is 35 mm, the radius of gear B is 125 mm. So we are given that alpha A is 3 radians per second square. Okay, and everything starts from rest, so we can actually determine omega A as a function of time. It's just omega naught plus alpha t, since alpha is constant, so this is 3t. And then we can also determine the angular displacement of A by using half alpha t square. This is 1.5 t square. Okay, so the question is asking for the angular velocity and angular displacement of output shaft C at t equals to 2 seconds. Okay, so at t equals to 2 seconds, we can find omega A is 6 radians per second, and then beta A is 1.5 times 2 square. This is 6 radians. Okay, so A is meshed with B. Okay, this means that omega B RB equals to omega A RA, and then theta B RB equals to theta A RA. Okay, so the angular displacements the displacements which is described in this equation, and the tangential velocity, they must have the same magnitude. Okay, so we can find omega B to be RA divided by RB times omega A. Okay, so this is 35 divided by 125 times 6, and then this is 1.68 radians per second, and then theta B is RA divided by RB times theta A. So same numbers, 35 divided by 125 times 6. Then this is 1.68 radians. Okay, so and then we say that we are given that B and C share the same rotating shaft. Okay, so this means that omega C is equal to omega B, which is 1.68 radians per second, and then theta C equals to theta B equals to 1.68 radians. Okay, so this is the answer for omega C, and then this is the answer for theta C.